So I just want us to start with this. The first four problems, we will use contradiction because the last one is clearly stated. In the test, there will be 10 problems to be done in 90 minutes. Some of them I will specify what type of proof I need. You must follow that specification. Others, I will just say, prove this. It's up to you how you prove it. And please do not use by contradiction. You do this, then you say, or it's waste of time. If you do that, I'll grade both of them, but I only record the least mark. So don't waste your time, don't waste my time as well. All right? Just stick to one method. And if you are using contrapositive, then you say, oh, by contrapositive, okay, or stating the contrapositive, or it suffices to show that, then I know that's contrapositive. If you are using exhaustion, you don't have to state the name of the proof, but at least explain what you are doing in details. All right? Okay, quickly. The first one, prove that this is irrational. What does it mean to be irrational? It means not rational. So if you go the contrary, you are going to assume that this is rational. Now, what does it mean for a number to be rational?
No roots in the bottom.
What?
No roots in the bottom of a fraction.
Not really. What does it mean for a number to be rational? Can be written as fraction in the simplest form, especially. Suppose that, on contrary now, this is rational. Because I won't tell anyone to stop writing, but if you get confused, then that's on you. Suppose that this is rational, it implies that we can write this as A over B. I'm going to introduce a notation now, where this is very important. GCD of A and B is 1. Has anybody come across this before? GCD means greatest common divisor. That's what you call HCF. So saying that the HCF of A and B is 1 means there is nothing to reduce again. It means they have nothing in common. Another way of saying it, instead of saying GCD of this, is to say, or you can say where A and B are co-prime. Co-prime means their GCD is 1. So these two statements are the same. Does it make sense? So we are basically saying if this is a rational number, then we can write it as maybe 2 over 3, 7 over 11, 9 over 20, and so on and so forth. Okay? Now, if this happens by your knowledge of logarithm, what can we do to this? Talk to me. Log 2 base 3 equals A over B implies what? What? That still doesn't help us. A over B. Law of logarithm.
3 to the power of A over B.
Again?
3 to the power of A over B.
3 to the power of A over B
equals 2.
It's easier to work with indices than logarithm when you are trying to interpret something. So that's why you don't try to change the base. Does that make sense? Now, what is the implication of this? Remove so that we can have 2 powers. It will be 3 to power A equals 2 to power B. Do you agree? How did I get this? What? Say that again? Yes, I multiply the powers by, so it's like 3 to power 3 over 2 equals 7. If you square both sides, now you see that? So basically this denominator is the power on the other side. That's what we did. Now, can somebody tell me why this is a contradiction? This is all you need to show. Someone, quickly, tell me why this is a contradiction. Because I've gotten to the point. Think. Because you'll be very good with simplifying, your algebra skill is But you need to get to a point where you notice, oh no, but this doesn't make sense. It's sometimes difficult to know, to see those things. That is why you need more practice. Somebody look at this and tell me how this doesn't make sense. By the way, we said these are integers. We should have said that. Where when you say GCD of two numbers, where should have said where for A, B, and Z this happens. Okay, so they are integers. So tell me, how does it make sense? I ask you to think. You're writing. I won't be the one writing the test on Monday, young lady. Yes, quickly. The idea isn't complicated, so stop thinking binomial theorem. Stop thinking De Moivre's theorem. It's something trivial. Yes.
To write them as fractions.
What are you writing as fractions?
Because A and B has to be fractions.
A and B has to be?
Fractions.
What do you mean fractions? A and B are integers. Why would A and B be fractions again? Yes.
3 to the power of A is an odd number,
Thank you.
and 2 to the power of B is an even number.
And so, how is that a contradiction?
Because they can't be the same.
They can't be the same. That's the contradiction. Powers of 3 are always odd. Powers of 2 are always even. So how can you say an odd number equals an even number? That's complete rubbish. That's a contradiction. And that's all you have to explain. This is a contradiction, or you can say, okay, this is a contradiction since left-hand side is odd, but right-hand side is even. Now that you run into a contradiction, and you say, therefore, log 2 to base 3 is definitely what? Irrational. Okay? That's a contradiction. Now, root 3. In your textbook, I think root 2 has been done as example, so you are free to look at that for your personal study. Let's try to do root 3 together. Again, suppose on contrary, root 3 is rational. Okay? Then there exists some PQ which are integers, okay, such that there is this PQ that are integers with, of course, not just integers, with what? GCD of PQ equals what? 1. Or you can say, or with another way of saying this, or you can say then there exists PQ in Z which are co-primes, which are, I'm trying to rush because of the time, which are co-prime, okay? Then such that, so either you say this, such that, or you say this and say such that, so it depends on which comes to your mind first. The two are the same, okay? Such that what happens, square root of 3 must be equal to P over Q. Does it make sense? So what do you think we would do? This implies what? Speak louder, please. What are you doing? Square both sides. So if you square both sides, 3 equals P squared over Q squared. What does this tell us? Or what does this imply again? You don't have to know what we are getting into, but you just have to think of what is the next commonsensical step to take. So don't try to think from here and you want to quickly arrive at contradiction. You have to take it one step at a time. Oh, with this, what can I say? With this, how can I go further? It doesn't have to be your destination, but you will now get to a point as you are going one step at a time you look at step 5, you think of what is step 6 likely to look at. With your step 6, not step 5, you think of what is step 7 likely to look at. It's possible when you get to step 50, then you discover, oh, okay, this is a contradiction, and then you stop. Nobody knows how many steps you need to take. Alright? So stop thinking too far. So again, what does this imply? What would you do, Karen, in this case?
Move the Q squared.
Just tell me what you write now.
3Q squared equals P squared.
That's it. P squared equals 3Q squared. Okay? So if this is the case, what does this mean to us?
P equals 3.
P equals, I'll help you here. This implies that Q squared is equals P squared over 3, correct? What does that say about Q squared? Yes, I just wrote Q squared equals this over 3, right? Do you understand? Are you following? So what does that say about Q squared? It's a multiple of 3. That's why I said the answers are simple stuff. A lot of you are thinking too much. Then when somebody say odd and even, oh yeah, you're thinking too much. Think of the basic things you can see. Okay? So with this, even if your so-called basic things isn't what we need, we will let you know. It says something about change your base. Of course it's right. But that's not what we need at this point. But at least it knows what that could be. That's how you should be thinking. Alright? So with this now, it shows that Q squared is a multiple of 3. Now, 3 is a prime number, isn't it? Okay, let's write it this way. Q squared must be, okay, let's say Q squared is a multiple of 3, or 3 divides Q squared. Is that okay if I write it that way? Let's write it first. Q squared is a multiple. No. Is it?
P squared is
P squared is the multiple. Alright? P squared is the multiple of 3. Because this has to be an integer. Right? So P squared is the multiple of 3. This implies that P squared is a multiple of 3. Or you can say 3 divides P squared. Right? 3 is a prime number. Right? A prime number divides P squared. What is the relationship between the prime number and P? Between that 3 and P? Again, 3 divides P squared. What is the relationship between 3 and P itself, not P squared now?
Wait,
Yes.
wait, but up there it said that both P and Q have to be prime numbers, right?
They never said
No.
so. And I'm not implying that. This says 3 divides P squared. This is a relationship between 3 and P squared. P squared could be like your 25. Right? So I'm now referring to 5, not the square that leads to 25. Are you with me? So if 3 divides the square of a number, what is the relationship between 3 and that number itself that will be squared?
Does 3 divide
Speak it again.
Does 3 divide
I'm asking, is that the relationship you want to tell us?
I don't know.
Think about it yourself. If 3 divides P squared, what happens between 3 and P?
3 divides P.
3 should divide P. Remember, P squared is P times P. If you are able to divide by 3 successfully, then you must have been able to divide by one of the components. Does that make sense? So the fact that, it's actually a theorem. If a prime number divide a square, then the prime number divide the square root of that number. Maybe I should put that in my test question. Just kidding. So this implies that 3 must divide P. Does it make sense? And the implication of this is that P can be written as some 3K. Agree? For some K in Z. Am I right?
Yes.
Now let's think back a little bit. Now that we have a format for that, let's put it back here, or maybe here, it doesn't matter. I'll say here. Okay? And see what we can deduce about Q. Maybe we can now run into the problem. So, P squared equals 3Q squared will now become 3K squared equals 3Q squared. Yes? Yes? What does that become? 9K squared equals 3Q squared. Now what does that imply? Jenna, can we see this part?
Yeah.
I'm afraid of this thing. Can you see it? Or maybe I write on the next line. It's okay?
We're
Yes,
going to take a picture later.
Alright, we'll take a picture. Okay, great. Okay, yes? What does this tell us? What is the implication of the last step? Speak louder, please. Just 3K squared equals Q squared. Okay? Now what is the implication of this?
3K equals Q.
What?
3K equals Q.
3K equals Q. Ow. You cancel K on one, you cancel Q on one. What is the logic?
Q
Yes.
squared equals
K squared equals, thank you.
Q squared over 3.
Okay, why did you say this?
I don't know. Q squared.
Q squared. Okay.
I'll be honest with you, I was just guessing.
But your guess is right.
The same step.
The same step. We are trying to use the same technique.
Oh.
Okay? Has anybody thought of why we are trying to use the same technique?
Because that means it's right.
Both have common.
Because that means they have common factor, and why is that a problem?
Because you said the radius and the divisor.
That's the contradiction we are looking for. They mustn't have a common factor other than 1. So if we are able to establish that there is another common factor, then this is absurd. So that's the reason we are going through the same step. There are different techniques of proofs. That is why you need to practice a lot. Okay? Now, this means that actually 3 divides K squared, isn't it? And that means that 3 has to Q squared, sorry. And that means 3 divides Q. Which means our Q is in the form of what? 3, whatever. There's a 3M. We can't use K again. So if Q is a multiple of 3, or 3 has a factor, Q has a factor of 3, sorry, then Q also has a factor of 3, then there's a problem. That's a contradiction. So your conclusion will be, so after this I'm going to write it, then you can quickly write something. So the conclusion will be, clearly, 3 is a factor of P and Q, which contradicts, then you quote this. Then therefore, the original statement must have been the other way. So I'm going to write that quickly now. Alright, so quickly take something down. So I said clearly 3 divides P and 3 divides Q, which is contrary to GCD of P and Q is 1. Therefore, root 3 is irrational. Okay, let's quickly take note of that. 3 minutes, please. as much as you can write in 3 minutes, then we come to the next one. If you're going to be slow in writing, take your time after the class. Okay? I just need to explain all this before the end of the class. And the reason I wanted to write something here is so that when I erase the board for maybe another question, we have space to write. But if you're not able to write everything in class, that's absolutely fine. Pictures will be posted on the group and the video will be on YouTube.
Let's use a picture now.
Yeah, of course, you could. Yes. Thank you.
What is the word after all?
After what?
All. Since it's
But, like B-U-T. Sorry. You can begin with suppose that and change the statement, or you can say suppose on contrary. It's okay, all right? Sometimes when people prove, they will write at the beginning, oh, we prove this by contradiction. So you already inform the reader that you're going to use contradiction technique, okay? Oh, I will prove this by contradiction. Then you say, suppose that this happens, okay? These are some of the terminologies, vocabularies that you have to get used to as you go higher and higher in mathematics. Due to the time, because we have lunch in about 20 minutes maximum, actually 18, can I ask you to please pay attention? Let's look at these two especially, then we will come back to the, I'm just going to explain the last part of this one. Actually, I'll quickly explain everything. Okay, let's look at this. We want to prove that root 3 plus root 2 is irrational. Of course, we know it's irrational, but you want to use something like this. So again, we use contradiction. Suppose, on contrary, so I already stated that, oh, I'm going to use contradiction. Suppose on contrary that root 2 plus root 3 is rational. Now in this proof, I'm going to be using this number 2. So in a standard exam, if you are going to say, oh, but recall that root 3 is rational, if it is not part of your solution, then that proof is incomplete. You must be able to prove that before you can use it in any result. As a matter of fact, if this was a standard exam in a university, what I use here, I need to try to prove it first. The idea that I use here is that if a prime number divides a square, then the prime number must divide the number below the square. If you get my point, that is the square root of that square. So I must be able to show that first. That is why when you read some paper, some of you writing your EE, you will see proposition, corollary, and things like that before a theorem. It means some other tools that are needed to prove the theorem. So you will prove those first, then you now recall it again. Does it make sense? Okay, let's move on. But you don't have to worry too much now. So suppose on contrary this is rational. Then there exists some Mn in Z, okay, which are co-prime, such that what? Root 2 plus root 3 equals m over n. Okay? The easiest way that I've seen is to move one of the root to the other side. Okay, because we're going to end up doing what? Can somebody guess? No. No jokes, please, no time. Because we're only going to end up doing what? Okay, if I do not even move to the both side, what would you do? Substitute what? The fact that I said we're going to use this doesn't mean we're going to copy our solution from here. When I say we're going to use this, I mean we're going to use this statement that root 3 is rational. Because at a point, that will help us to lead to contradiction. So you don't have to think about this yet. This is being used at the last stage. So, but before we get there, what do you think you do for it, even if I've not told you about this? Can somebody guess quickly? We don't have time. We're running out of time. Let's make a guess. Yes? Square. You square both sides. And when you square, you're going to end up getting something like root 2 and root 6. Yes? And we have no result on root 6. Rather, we have a result on root 3. Okay? So this is the reason one of these will go on the other side. So that I can have a root 3 to deal with. Okay? So I will take this to the other side. Then I have root 2 equals m over n minus root 3. Can we see that? And this implies that, because of the space, I write it here. So this implies that we can square both sides. And this implies that we can have 4. Yes? No, 2. I have 2. Then this will be m squared over n squared. Then 2 root 3 m over n plus 3. Yes? This 2 and 3 can be subtracted. Yes? You can maybe bring it here. Or no, you can actually bring, this is negative. Let's try to see positive. So this negative can be here. So you have 2 root 3 m over n equals what? M squared over n squared. 3 minus 2, 1. Yes? Let me try to isolate root 3. Okay? I'm going to try to isolate root 3. If I want to isolate root 3, I'm going to multiply both sides by n over 2m. You agree? So that this can cancel the one below and this 2m can cancel the one above. However, before then, this is m squared plus n squared divided by n squared. Yes? This is this. Okay? So, it means my root 3 will be n over 2m multiplying m squared plus n squared divided by n squared. Yes? Talk to me, please. Yes. Krista, are you lost? Are you? Okay. So this will be root 3 equals, what is the simplest form? You have m squared plus n squared divided by 2mn. How is this a contradiction? That's it. This is irrational according to 2. But this is rational. Integer over integer is rational. So this is a contradiction. So if this was in an exam, this would probably be A, then this will be B. Then you can say, oh, according to A, because you have already done it, then you can make use of it. But if this is the only question and you get to this point, you stop here, then you now say, oh, you now try to prove, now I prove that root 3 is irrational. You can call this maybe equation asterisk. After you prove that root 3 is irrational, and as it ends from equation asterisk, it means there's a contradiction on this step. Because sometimes you don't know what you might encounter to use. It is when you get to that point you realize, oh, I'm going